Hello everyone, I am here today to talk about this Goldenmate UPS. In addition though, I'm also here to talk about all the things I've been working on in the background to improve the energy reliability in my home lab. So if that sounds interesting to you, then come along on this adventure. Here we got the box for the UPS. Let's take a look at what's inside. It says 1000 VA, 800 watt. So yeah, specs. Up on the end, so it says it's a LifePo4 battery. 230 watt hours, so that would run me, I don't know, maybe an hour or two of runtime with my desktop, so that's pretty good. Despite being lithium, this thing is not light. There we go. Standard IEC power cord. Yeah, so it's white, Goldenmate, 1000 VA. Front side is pretty bare. I have a peel on the digital screen and a power button. Oh, okay, it turns right on. So on the back side we have the IEC input. This is the standard IEC input. I guess that's the circuit breaker. This is probably the RS-485 port. That is a very interesting choice of connector. I'll have to zoom in on that in a sec. And we've got 4 standard US power jacks. So at the time I accepted this, the website said it had an RS-485 port. And I was going to try to communicate with it to see if it supported some sort of UPS software. So here's the connector for it. It's behind this little jacket, and it's a very maybe I'll zoom in on software for you guys, but it's like a relatively nice looking metal round connector. Kind of reminds me of a Limo connector, if any of you have heard of that, which is probably too expensive for this device, but yeah, so I might plug into that and see what's on it, but the website doesn't mention it anymore, so that's interesting. So the manual actually does mention it. So it says communication port debugging interface which cannot be used with server. So I was kind of hoping to use this with a network UPS server, but it's actually made for my desktop anyway, so maybe I'll still probe that and see what's going on. So I've got the thing hooked up to a mini PC as a load. It's powered on. We're going to take a look at the waveform on my little oscilloscope here. So this is dangerous. Don't do this, but I know what I'm doing. Come on, make a good contact. There we go. So that's what our waveform looks like on the grid. And then we'll just go ahead and eat that plug right out of there. Still looks fine. So waveform looks pretty good to me. Thing's beeping at me though because it lost power, but whatever. Stop beeping. So next up I got the multimeter on this connection on the back. And I'm going to probe around. There's 4 pins, so 2 of them should be RS-485, and I'm going to see if I get a signal. I'm hoping this thing just spams messages out all the time, and that'd be great. Then I don't have to figure out what the protocol is. Well, I'll have to figure out half the protocol, I guess. So let's see, I should probably zoom back in because I was on 100 volt. So we'll go to 2 volts per division. We'll just randomly pick any 2 pins here. So I don't see anything there. Yep. That's to ground. That looks like something. Could just be noise though. Okay, so that pin did not give me anything. Let's try this pin. Oh yeah, that is just noise. That's from my fingers. Yep, so I'm not finding anything. Guess that means this serial port will be more challenging for me. So at this point, I hooked the UPS up to my desktop upstairs, booted it up. All was well and good. I let it charge for about a day just to make sure it's ready to go. And then I spent half an hour playing games. So my computer was drawing about 300 or so watts, so not a huge load on the UPS. But I gamed without power into the UPS for half an hour. It sat there slowly beeping, and it was just fine. So the battery monitor said it was down to, I don't know, 2 bars out of 5 or something. So capacity seems at least reasonable. So I am satisfied with that enough to keep it up here on my desktop, protecting my computer from the power outages we get all the time. So now I'm down here with my breaker panel to tell you about all the energy problems I've had over the past 3 weeks. In that time, we have had a total of 8 power events where the UPS has interacted. Event number 1, the day after I plugged in the UPS, the power went out at 5:30 in the morning. the UPS started beeping to indicate that it had lost power, and that woke me up, so I turned it off. I will say it did not make the ugly line frequency hum that my APC UPS makes from its massive line frequency transformer, so that's, I guess, something. Next event was a bit longer, lasted for 3 hours. Thankfully though, at hour 1, we were able to wake up and plug the house into the truck. So the battery only had to power my computer, which was also turned off, so it was only idle power for about an hour, but the computer didn't lose anything, so it came up from standby, still had everything it had before. Then we had a week that was rather hot, and in that week, we had a blip, a total of 6 times. So a blip is where essentially a circuit breaker on a utility line trips, and then a recloser closes it again about a second later. So power line somewhere, shorts on something, probably a tree that they didn't bother to trim, or I don't know. And then lights all dim, then breaker cuts, everything goes off. Then about a second later, everything comes back on again, and it's fine. And it stays fine for maybe a day if we're lucky. So of course, normally when this happens, I would lose everything I'm working on the computer, such as, say, recording a video, which happened to me last night. Very frustrating. Also have to reset all the clocks, the microwave, all that kind of good stuff. And at least I didn't lose any data this time because I had the Goldenmate UPS. It was not powering my camera because my camera was on the other side of the room, but it was powering my computer and all that other good stuff. So it only interrupted my recording session a little bit. And of course, my utility company also raised my rates this year because they're working to improve reliability, I think. So that brings me to my grand project down here. So I haven't made any videos about it because it's kind of been a long project so far, but got 2 breaker panels here, and a year ago I only had 1. So this is part of my long-term plan to improve my energy reliability, because obviously DTE Energy is not going to do their part. So what I've done here is I've taken my main panel and I've split essentially all of the circuits into a sub-panel. So this is the sub-panel. It's actually the original panel in the house. And so I added a new main panel in front of it. And this has the really, really big circuits in it. So it's got the air conditioner, the 2 EVSEs, and the big oven. And then it has a 60 amp sub-feed to the sub-panel, which has all the lights and plugs and stuff, general stuff. So the idea is, if I can find an inverter and a battery system that can handle the power used by this panel for about 3 to 4 hours, I'll be able to handle almost all of the power outages we get here. And worst case, at hour 2 or so, I'll usually be able to plug into the truck. And that'll have a much bigger battery pack to draw from. That's the goal, at least. Of course, that's a very expensive goal, so I'm not going to be investing too much in it rapidly, but I've done this in preparation for that. Doing this also means that the sub-panel now has a generator interlock, so I can switch it over to the outside outlet, which I can run a cord out to the truck, plug it into the truck, and that gives me power if the power's out for a long time. And of course, everything still turns off and back on. I have to go drive the truck over there, plug it in. It's not seamless, but it's better than just being without power and without water for days. I've also been a bit too busy to reinstall my energy monitor, but about 5 or 6 years ago I put this energy monitor in, and it measures the power from every single circuit in the breaker panel. And this was what really helped me in sizing a lot of the things in this breaker panel. So if you look at sort of a sizing estimate of how big a panel should be, it'll give you some number that this needs like 160 amps or something crazy. But the actual data from the energy monitor shows that this would be perfectly fine with a 30 amp feed. Double 30, 240 volt 30 amp. And of course, that's because this panel doesn't have the car chargers that need like 32 to 40 amps each. There's 2 of those. There's also the electric oven, cooktop, and air conditioner, but those are kicked out now. So anyway, that's where I'm at. The Goldenmate UPS is a nice, tiny lithium-ion UPS. I thought it worked fine for me. I compared it to some comparables on Amazon, and it is about the same price as a name brand for a higher capacity, and I think that's a reasonable choice. If you want to follow along, I have a Discord server where I chatted about this very topic here. I have some other things I talk about too, like networking, a little bit of home automation, that kind of good stuff. So Discord link down below. And as always, see you guys on the next adventure.